Hi, this is Miss Harkness, and in this video I'm going to show you how to describe a sequence of transformations that includes dilations. So this is actually from lesson 7. It's a pretty simple method, same as we learned in 8GA2, but in this case we're GA4 because a dilation is part of the sequence. So same 3 steps. Step 1, we're going to label the shapes. Step 2, we're going to look at shape 1 to shape 2, look at how that was transformed, and then we'll end with our final step is looking from shape 2 to shape 3 to see how it was transformed as well. So step 1 is label. Just in looking at this diagram, I can label based on the prime notation. So I can see that my blue shape is shape 1 because it does not have prime notation. I can see that my black shape is 2 because it has that individual prime on the labels, which leaves me with my orange shape for shape 3, because it has that double prime notation. Step 1, label, done. Step 2, we need to look at shape 1 to shape 2. So my blue shape to my black shape. It's pretty obvious to me that this shape has been reduced. So there's a dilation happening here. So from shape 1 to shape 2, it is a dilation. And we need to say the scale factor. So with a scale factor, and then let's go look. 1, 2, 3, 4. So B to A was 4 units. 1, 2. Now it is 2 units. So that is a scale factor of 1/2. As a review, scale factor is new over old. So if we were to do 2 over 4, that equals the 1/2. Okay, so far so good. We've found shape 1 to shape 2, check. Now we need to look at shape 2 to shape 3. So I am looking at my black shape here, which I'm highlighting in orange, to my orange shape. Now I want you to notice a couple things. You might think it is a reflection. It looks like it could be a reflection over the y-axis. However, when you look at the labels, if this was a reflection, B double prime would be on top, not below. If it was a reflection, A would be opposite itself. So let's write down a pair of ordered pairs to see if that helps. I've recorded the coordinates for A prime and A double prime. You'll notice that the x and y values have switched. So it has to be a rotation. Which rotation rule has the right side staying the same, right? That -2 came over. And then because it's 0, it's hard to see, but the left side got a new sign. This is a 90-degree counterclockwise rotation, and that problem is complete. There is my sequence. A dilation with a scale factor of 1/2, followed by a 90-degree counterclockwise rotation. That is how you describe a sequence of transformations with dilations.